Welcome to lecture number 6 for our lighting class. This one is on controls and documentation. And first of all, chapter 18 of our text is on lighting controls. These are otherwise known as switches. And there are basically four different types. I'm sure people could come up with a few more, but there are some that are based in the lamp itself, so the light source itself. Some are luminaire based. Again, LEDs don't always have a lamp, so the luminaire-based controls, room-based, and then there's whole building or partial project control systems, which are typically automated. Lamp-based controls, you can actually get these on Apple, the Apple webpage. They always find a way to sell you stuff. But also, Amazon and that sort of thing. There are all sorts of light sources that can be controlled either with an app, as in these Philips Hue lights, or with a remote control. And basically, you get the app, you can dim the light or increase its brightness, and you can even change the color temperature of the light remotely, just like the panel that I've shown you guys in our classroom. Luminaire-based controls. These are things you're probably all familiar with. Rotating switches, pull strings, touch plates. You can actually, some fixtures, you just touch the fixture and through capacitance it activates or deactivates the light source. And then there's the clapper, which is an audio-based control. And again, these are things you're probably very familiar with. There's little twist dials and things like that, but there's all sorts of things, pull strings, floor-based switches, even things that go inside of plumbing equipment to turn the light on and off. So room-based controls, you probably have seen these as well. These are switches. Toggle switches are the on-off switch, but usually when you have more than one, it's called a gang of switches. Often when you walk into our classrooms, you'll see 3, 4, sometimes even 5 switches all together. These room-based switches can have different flavors, things like timers, occupancy sensors, daylight sensors, some of the things we've talked about. And you can have centralized control and dimming systems, but that are activated by timers and sensors in the room. So anyway, I like this. The book has for years always had this lovely hand-drawn drawing of a switch. I don't know why, I just think that's funny, but it's funny. Anyway, obviously you've seen these sorts of things. One of my big pet peeves is that we all spend all this money on beautiful, expensive finishes, cool lighting, and then we go and choose the crappiest plastic light switch plate out there, or we don't line it up with the ceramic tiles, as in this image, which is actually from Lutron, I believe. So, it just kind of drives me crazy. Now, at least this thing is square and it's probably a nice material, but why choose plastic? It doesn't go with stone, and yet it's one of those things. And it's one of those things we interact with every day when you walk into a space, and yet we often, most of the time, choose the cheapest garbage out there. So anyway, there are all sorts of fixture light switch covers that you can get, including square, and you can get these metal kinds. There's a million different things. There's whole swatch books filled with these things. So why choose boring when you can choose nice? Anyway, some of these switch plates, and we have one of this type in our classroom, can also have these preset scenes. So, for example, if a speaker is in, you press that button and it has automated settings for dimming or turning on lights. And those can even be coordinated with the shades as well. Let's say you have a video presentation going on. It will dim all the lights except for maybe reading lights, and it will shut all the screens. So now, centralized controls take that one step farther. These often have local monitoring of individual rooms, but then via typically computer, some sort of network connection, you can control all the lights in the building or in your project, the ones that are within the scope of the control system. These are obviously terrific because let's say you have a building where it's really hot on the first floor and really cold on the second floor, you can turn down the heat on one floor and turn it up on another. You can take advantage of the heat load of the light sources and coordinate it with all sorts of other systems to monitor the performance of the building and really tweak it. For example, if it's a sunny day and you have a south-facing atrium space, that space is going to really heat up. You can adjust your HVAC system right away. Anyway, and all this stuff is great for facilities management, which, by the way, is a terrific career option. Those of you who haven't decided what you want to do when you grow up, facilities management is an awesome use of interior designers' skills. Kind of an aside. Anyway, Lutron is one of the big players, and they have on their websites all sorts of really terrific interactive information about how to specify these systems. And the Sivoia QED from Lutron is the dimming system or the shade control system that we have in our lovely classroom. There's other companies out there too. I don't mean to be plugging Lutron, Light Touch, and Wire Mold also have those types of products for switches. All right, and now in a switch, we will go to Chapter 19 and documentation. And typically when you're documenting lighting, you talk about the reflected ceiling plan. That's where a majority of the lights do occur. So obviously you do have to locate the equipment. That includes both drawing it and including dimensions. If you have a ceiling grid, you don't need dimensions, although you should put a dimension to locate the grid. Typically you center grids on the whatever construction is around it. You'd need to indicate that somewhere. But anyway, also if there are any special configuration of the ceilings, like the dimension of soffits, you would put dimension strings in there. And usually I recommend dashing in items that occur below for reference. Just lighting items, not usually the furniture, unless you're making a special effort to align the lighting with the furniture. Sometimes what you see in simpler projects is kind of an all-in-one plan where there's things like lighting. Then this little symbol here means a switch. A duplex receptacle, a plug, basically. This little $sign means a switch, and then the $sign with a 3 is a three-way switch. I'll take a look at that a little bit larger. There's also a triangle thing, which is the usual symbol for a data port or the phone. So there's a lot of information in here. This is the switch for this light fixture. This is the height for this plug, which might be high because of a stove or because of a work surface. There's all sorts of things that you include in these squiggly lines that connect the fixtures. Those are indicating switching. Okay. Now, from the book, some examples of something more than just a sort of schematic view for a larger project. During design development, you will absolutely identify every fixture in the project. Sometimes you will dash in the furniture like they have here because the lighting is making reference to the furniture. They want to align it. And then every unique luminaire gets a different symbol. So this is a wall washer. See how one side is closed. These with the arrow are directional, and then these are downlights. And each one gets a letter. And it's ideal if the letter doesn't obscure some piece of the architecture. It looks like there's some soffits in there. Now, during construction drawings, and again, this is just a partial plan, you see how every light fixture now has a dimension. They often use this CL, stands for centerline indicator, to indicate that you want this light fixture in the middle. Now, another dimension that is seen frequently is equal. Equal. So if you want something spaced equally between two objects, you'll put in that equal A. I'm not sure where the other equal is. Anyway, every light fixture needs to be located in the room, both off of both walls, both the left to right and the top to bottom direction. So during the construction drawing phase, you also do what are called lighting control plans, or dimming and switching plans is another name for them. And with each of those, every office has a different style, and I'll show you more examples in a minute. Typically, you'll label each fixture like we did before, A, B, C. I usually use the same symbols as in the reflected ceiling plan, but here you see how there's a code next to each one that relates to the circuit that that light switch is on. Okay, so some people draw the circuiting using dashed lines, kind of squiggly lines. In this case, they've indicated it numerically. So either one is correct. So talking about dimming and switching plans, let's take a look at those. Basically, you typically have a reflected ceiling plan and a dimming and switching plan. So two separate reflected ceiling plan style views. The reflected ceiling plan, like I mentioned earlier, is to show the kind of design intent, the major elements, and the location of the light fixtures. It's also usually where you coordinate with things like HVAC supplies and returns and sprinkler heads, all the other garbage that goes up in the ceiling. The dimming and switching plan is where you show how those fixtures are turned on and off, and if they're ganged together so that several fixtures are controlled by one switch. This is where you show it. Now, the two styles, you can either literally graphically connect each and every light switch to the fixture that it controls, or fixtures. Otherwise, you can do like the previous example where you label the circuits. Okay, so here's an example of the first one where you can see here there's a bunch of dollar signs. The dollar signs are switches, and here they're indicating some existing and some new. Really, some of these are three-way switches because there's two switches. The reason they call it three-way is because it can be either on at this switch, or off, if that makes any sense. So anyway, but you can see they graphically connected every single fixture. You can also do it this way where you graphically connect the fixtures, but then you label the circuits. And this is easier when you have a lot of lines that are all coming into a really small area. So instead, they just use this graphic technique. And this is really nice. And then some people will actually leave out these lines as well. I like to keep them in just for clarity, but that's just me. Anyway, you try not to cross those loops if you can avoid it. Now, another thing that you can do in these dimming and switching plans is indicate if there are preset scenes. So, for example, you may have individual lights that are dimmed to specific percentages based on some effect you want to create. You can use this switching plan view to create those scenes. Now, the other thing that we do as interior designers is we come up with details where we put lighting in different configurations in a space where it's more built in, or we're just trying to indicate a special effect. These are also, again, done in construction drawings where you want to indicate the finished materials of all surfaces. All interior cove surfaces must be painted high reflectance matte white, typical. But you'll also want to indicate all dimensions, including clear dimensions, if there are any lips or mounting heights or angles, and obviously the equipment, the lighting equipment that you're going to use and its configuration. This is a wall washing fixture, but they're using it to wash a ceiling, so you have to make sure that the reflector is facing the correct way so that the light gets reflected out on the ceiling. Even something like this, which is actually probably more of a design development type of drawing, because really there's not much information here. It seems like you would want to design that niche. But you can see that they've indicated the mounting height. This bullet is a elevation bullet, so it shows the mounting height. Or something like this, where it's a large room or building section. They're indicating a ceiling effect here with these, whatever these are, Luminaire type D. They have heights indicated above the floor. You can see they've kind of not done the entire building, just this one effect. But then there's a detail indicated with this dashed call out. And here's where they show how that actually works. Oh, there's a beam in there, and they have some finished material. Here's the wire, and some kind of metal mounting bracket. Okay, so kind of going from large scale to smaller scale. And same with something like this. This is often, we do this sort of dropped ceiling with lighting above it. This is kind of how you would detail that. Here's the ceiling system, how it all goes together. And then here's how they've mounted the light fixture. Or again, something similar. Here's this same kind of trim. A composo trim is like a rigid trim that you can put around like a drywall cloud. It's flexible. Anyway, how does that all go together, and where do you want this light fixture to be? Or something like this where it's adjustable. They've dashed in or grayed in the adjustability feature. Or the looks like there's two light sources. And again, this is a ceiling slot, so it's yet another kind of construction. Or here, again, another detail. We don't have to go into the details of all the details. But again, you start with your design, and then you move on to the more detail-oriented drawings. Anyway, schedules are the kind of last part of the puzzle here. And schedules are really important sort of for keeping track of things during construction drawings. This isn't something that we will be doing in this class, not certainly lighting control schedules. We'll just do an in-class exercise for scenes. But you can see here that typically the lighting controls, you have zones, or you have each light fixture listed, the zone that it's in, how many fixtures there are, the wattage, and the type of controlling. So you can see that in the end you can calculate loading, which is important. Lighting equipment schedules, as opposed to switching schedules, typically you use a schedule, and this one is straight out of Revit. It's a Revit style. Every light fixture gets a letter. Okay, rule number one, every unique type of light fixture gets a letter, not every single one. You can drag the symbol into the schedule too, I believe. You have to describe it. The Revit descriptions are sometimes not very clear, but usually you want to show the mounting, the lamp type, and the light distribution. Nowadays, the lamp type is typically going to be LED. But anyway, if there is a unique lamp, you'd have it in a column here. You'd have the manufacturer, catalog number, all that kind of stuff. So, and these can be quite large and quite onerous to fill out, to tell you the honest truth. The other thing I wanted to talk about today, the book doesn't talk about it a huge amount, but it's kind of one of those things that I think is important, which is coordination with the other systems in the project. Now, first of all, usually as an interior designer, you're either working with an architect who's designing a building, or you're stuck with some crappy existing building that you have to deal with. So you have to understand how those structural systems work so that you can figure out where you can run your lighting and your ductwork and all that kind of stuff. So something like a steel beam system here is very flexible within each bay, but it's really hard to cut holes in those steel beams. They become less structurally sound. So you have to go under them, which of course limits your ceiling height, especially when you consider ductwork. Whereas these open web steel joist systems are really great because they're open. They have an open web. So you can usually sneak the ductwork in there. Concrete, of course, is very inflexible. And something like a waffle slab, which is awfully tasty, but is extremely inflexible. It's super hard to work with. You basically have to go around all the pieces. Anyway, you do need to know how to read ductwork drawings that you'll get from your engineering consultants. They usually have a key. This is a key off of key from one of the drawings that indicate how what they're showing you. The big thing is the diameter of round ducts or the dimension of rectangular ducts. That's what's going to kill you or help you with your ceiling heights. And basically, these systems have a central air supply somewhere, like in the art center. They're up on the roof, which is why all of our ceilings vibrate so much. And they supply air into a room, and then it gets sucked back out of the room and into the HVAC system. You need to accommodate all that stuff. And you can see here, this is a HVAC plan that I swiped from somewhere or other, that overall they show you the duct sizes, and then within each room they may actually indicate the duct size more abstractly. This is a 10-inch diameter. It looks kind of like a dryer hose. And when you kind of zoom in on that, you can see these are the sizes of the duct. This one is 8 inches in diameter, whereas this is 10 by 12. And these diffusers, by the way, they're all sorts of different kinds. I mean, we're used to just seeing the boring kinds that are square. But you can get little teeny tiny slot ones that are high velocity ones. They can be round, or they can be very linear, or they can be encapsulated within the light fixtures. In fact, that's a fun thing to do, is to choose dimensions of things, or I'm sorry, choose a design for the fixture that is interesting, the supply and return registers. But anyway, the other thing is that you have to consider the dimension of the light fixtures that you have in your ceiling and how that's going to impact ductwork. So, for example, if you have light fixtures that are 8 inches high, that's fine. That might squeeze into residential framing. But what if you need to get a duct above this? Well, a 12-inch duct above this makes it absolutely huge. So you need to be aware, like fluorescent lights can be pretty flat, but some incandescent lights can be quite tall. And even LED, if they're low glare, can be quite tall. So, and I did this little diagram to indicate to you, all the junk that goes up in the ceiling. You start with your HVAC system, and this is kind of what we have in our classroom. You have a main trunk line, which often can be quite large, and then you have these sub lines that come out. And then you have return registers in the ceiling, and the whole ceiling is basically acting as a giant duct, which is kind of not so great because they get pretty dusty after a while. Then you have your sprinkler heads in there, and everything wants to be right in the middle of the room, which is why if you have an open web steel joist, at least some things can squeeze in between those joists. Not the ductwork, but the plumbing, and then or the sprinklers, and then you've got also like the recessed lighting. Like I mentioned, those have some dimension. So getting all those things in there is quite a challenge. There are a few other things that we stick up in our ceilings that typically you use rules of thumb to get you kind of through the design phase, and then during design development in a larger project, you would usually have some consultants that you'd want to call in. So, for example, sprinkler spacing, rule of thumb, 7'5", maximum from the sidewalls, 15 feet on center, maximum from each other. Great. But what if you have 8-foot ceilings instead of 12-foot ceilings? Well, the spacing actually changes. So, sooner or later you need to call in a specialist to figure that out. Same with the mounting of alarms. Typically, these are near the exits. Visual alarms need to be mounted at a certain height. Audible alarms need to be mounted at a certain height. So all of these things, are required, and some of them are going to occur up in the ceiling, like exit signs or smoke and fire detectors. Others are not. HVAC, as a rule of thumb, you should have a supply register every 250 square feet, return register every 1,000 square feet, but again, varies quite a lot based on a number of features. Wireless internet. I'm sure you've all heard of the internet. Well, it gets to you somehow magically within a building. That's the Wi-Fi that I'm talking about here. Typically every 100 feet, 150 feet within the line of sight. But if you're in individual rooms, it's typically only every 50 feet. I think each of our interior design classrooms has its own Wi-Fi repeater. And then there's other stuff, AV equipment, projectors, televisions, sound systems, smoke and fire detectors. You need these, one in every enclosed space and then one every 50 feet in things like hallways. Some are heat sensitive, some are optical, and some are both. And these are typically hardwired with backup batteries. And obviously hazardous occupancies are going to need some specific stuff. Exit signage too, that's one of those things that people tend to sort of just leave it to last and not really think about it, but there is some nice stuff out there. Obviously you need an exit sign at every exit, right? That's why it's called an exit sign. But also, some of you may have seen one of these. These are battery backup lighting system, emergency lighting. Now, this one is a dedicated emergency light. What we typically try to do nowadays is use one of the fixtures in our ceiling as the emergency light. Sometimes that just doesn't work out, but usually we can do it nowadays. And then, like I said, exit signs, some are nicer, some are pretty darn cheap. Smoke detectors are also hardwired, and again, also in the corridors. What's funny about them is that you also need them above ceilings and inside ductwork. And again, this is something your consultant usually worries about. While I'm here, I talk about manual fire alarm pull stations, which are not on the ceiling. You don't typically show those on your reflected ceiling plan. But as long as we're talking about all this other stuff, strobe lights and that sort of thing, we might as well talk about fire alarm pull stations. Again, not required in residential applications, but for all non-residential applications, I believe they are required. So, same with the visible audio and audible alarm signals within 5 feet of all exits, along path of travel. And fire extinguishers. Again, not required everywhere, but you do need them. In fact, I do believe you need them in computer rooms, and I'm not sure we have them in our labs. Anyway, in summary, when you're talking about switching and controls, consider where you want the controls to be. And the aesthetics of the switch hardware. You know, it's really cool to have switches that are all, I don't know, voice activated. You know, and then you don't have to worry about the aesthetics, or do you want to make some sort of statement with the switches? You can use scenes to dim the lighting for all sorts of different effects. And that is going to be something that we're going to work on later on. And when you do construction documents, this is really kind of the last piece of the puzzle. That's when you really take your design intent and you start doing detailed drawings that show how all of your light fixtures are arranged dimensionally in a space. And if you have any custom lighting configurations or ceiling construction, that's where you indicate how it's built. You provide all sorts of schedules, which is sort of how people buy out the project, as they usually use your schedules. And make sure that you coordinate with all building systems, including HVAC, plumbing, electrical, and the structure.